Hello again. The newest release of SharkC64 has many changes and improvements. As the main new feature, it has now an integer data type. Let's have a look. The need for integer values came up in usability tests. For instance, simple motion with sprites can be implemented just by using bytes and words. However, complex motion tends to mix values and directions. And that gets very ugly very fast if you cannot express both the value and the direction with one variable. This is exactly what an integer variable can do. In SharkC64, an integer value is a 16-bit signed value. Therefore, the value range is from minus 32,768 to 32,767. In contrast, the value range of a word is from 0 to 65,535. From a technical point of view, integer and word values differ only in how they are compared. For words, the comparison is restricted to positive values. The comparison of integer values works with both negative and positive values. In particular, a comparison like this fails for word values. The expression 0-5 causes a value range overflow, resulting in a value 65,531. It's clearly not less than 5, and the comparison fails. This does not happen for an integer value. As for the implementation, the microprocessor of the Commodore 64 does not support comparison of signed values. For the comparison to work, an integer value needs to be shifted from its value range to that of a word value. Then the lowest value is mapped to 0 and the highest value is mapped to 65,535. All the values in between are mapped accordingly. You could achieve this by using addition and branching operators. There is, however, a clever trick that can be used instead. All you need to do is to flip the most significant bit of an integer value with an exclusive OR operator. After that, you can compare the values as if they were just word values. The reason why this works is that an integer value is represented by using 2's complement. So, the comparison of two word values A and B is done like this. By using the trick, the comparison value of two integer values, I and j, is done like this. So the cost is only in the storing of a temporary value with the flipped highest bit. And this is what the SharkC64 compiler does behind the scenes. To see how the integer values are used in practice, let's open the latest example. This example draws a wave on the screen. Let's first run the program to see what it looks like. And there's the wave. Now, if you look at the program, it uses byte values x and y to draw on the screen. It then uses integer values a, v, and s to compute the waveform. The movex function computes the horizontal motion, and the move-y function computes the vertical motion. The move-y function simulates the behavior of physical acceleration and velocity. It switches between acceleration and deceleration when a maximum velocity is reached. The move-y function also updates the y position only when a specific vertical distance has been reached. Clearly, this does not compute any accurate physical motion, it merely simulates one. The use of integer values makes the computation clean. The same computation would require extra variables if it was done just by using word values. It would also make the program harder to read. So that is the new integer data type. Next, I will implement a new demo project with sprites. Until then, thanks for stopping by and see you soon.